Welcome to Math and Engineering. We have another interesting question. We are asked to calculate the length of the red line, that is this here, say x. The length of this line segment is 6 meters, while that of this is 16 meters. The size of this angle is 60 degrees, and similarly, the size of this angle is also 60 degrees. If you look here, this line and this line are congruent. The same is here. This side and this side are congruent. So how can we solve it? How can we calculate the length of this red line? Well, like always, it is very simple. The first thing we are going to do, we'll come here, label this point P, this Q, this R, this S, this T, and this V. Now let's look at this triangle PQR. We have this side and this side to be congruent. Definitely this angle and this angle will also be congruent. And we have the size of this angle to be 60 degrees. Based on the rule that the summation of angles in a triangle is 180 degrees, this angle and this each will be half 180 degrees minus 60 degrees. 180 minus 60 degrees is 120. 1 over 2 times 120 degrees is 60 degrees. That makes the triangle an equilateral triangle. An equilateral triangle has all its sides to be equal in length. That is, this side, this, and this are congruent. So if we assume the length of this side to be A, this and this each will also be A. But as for this side, since it is intersected by this line, we write out its length here, line QR equal to A. The same thing we did for this triangle is applicable for this triangle also. Since this side and this side are congruent, and we have this angle to be 60 degrees, this and this each will also be 60 degrees. But if we let this be R, this must be 60 degrees minus R. We are sure this triangle is also an equilateral triangle. So if we let this side be B, this and this must also be B. But as for this side, we write out its length here, line RT equal to B. Let's not forget here also, if we assume the size of this angle to be S, this must be 60 degrees minus S. Now we come here, look at this angle 60 degrees. This angle, assume its size to be M. This angle say N, and this 60 degrees, they all are lying on the same straight line. And we know the angle in a straight line is 180 degrees. That is, the sum of this angle, this, and this must be 180 degrees. So 60 degrees plus M plus N plus 60 degrees equal to 180 degrees. Here 60 degrees plus 60 degrees is 120. So M plus N plus 120 degrees equal to 180 degrees. Subtract 120 degrees from both sides. Here 120 minus 120 is 0. While here 180 degrees minus 120 degrees is 60 degrees. So M plus N equal to 60 degrees. That is, the sum of this angle and this is 60 degrees. Now look at this triangle QRV. We have the length of this side to be B, and this side QR, its length we have here to be A. This angle between them is the sum of this 60 degrees, this N, and this M. The same is for this triangle PRT. The length of this side, we have it here to be B, and this side has its length to be A. This angle between them is the sum of this 60 degrees, this n and this m. This fulfills one of the criteria for the congruency of two triangles. This S represents pairs of corresponding congruent sides, and A means the angle between them is the same. That is, this triangle QRV and this triangle PRT are congruent. Now, since they are congruent, this angle facing this side with the length A in triangle QRV must be equal with this angle also facing the side with the length A in triangle PRT. So since this has its sides to be R, this must also be R. Similarly, this angle facing this side with length B must also be congruent with this angle also facing this side with the length B. So since this is S, this must also be S. Now we come back here to this our equation, m plus n equal to 60 degrees. Subtract n from both sides. Here n minus n is 0. So m equal to 60 degrees minus n. That is, this m is 60 degrees minus n. Now look at this quadrilateral RSTV. We can see this side subtend this angle and this angle to the vertices of the quadrilateral RSTV facing it, and the two angles are congruent. That is a property of a cyclic quadrilateral, meaning this quadrilateral is a cyclic quadrilateral. So since this angle and this angle are both subtended by this side, they'll also be congruent, and we have this to be 60 degrees minus R, while this is 60 degrees minus n. Therefore, 60 degrees minus R equal to 60 degrees minus n. Subtract 60 degrees from both sides. Here 60 degrees minus 60 degrees is 0. Here also 60 degrees minus 60 degrees is 0. So minus R equal to minus n. This minus cancels this minus. So R equal to n, which means n equal to R. We come here, replace this n with R. Also here, substitute the value of n. So it is 60 degrees minus R. The same is for this quadrilateral PQRS. Both this angle and this angle are subtended by this side to the vertices facing the side. They are congruent, and that proves it is also a cyclic quadrilateral. So since this angle is also subtended by this side, and the same side subtend this angle to the opposite vertices, they'll be congruent. So since the size of this is R, and this is 60 degrees minus S, that means R equal to 60 degrees minus S. Come here, replace this R with 60 degrees minus S. Minus 60 degrees minus S is minus 60 degrees minus minus S. Minus minus S is plus S. 60 degrees minus 60 degrees is 0. So the angle is S. Now look at this triangle. It has an angle R and an angle S. The same is for this triangle. One of its angles is R and the other is S. That proves that the two triangles are similar. So if you take the ratio of their sides, this side facing angle S divided by this side facing angle R must be equal to this side also facing angle S divided by this side facing angle R. So x over 6 meters equal to 16 meters over x. Cross multiply. Now x times x equal to 6 meters times 16 meters. X times x is x squared. So x squared equal to 6 meters times 16 meters. Take the square root of both sides. Here square root of x squared is x, while here square root of 6 meters times 16 meters is square root of 6 times square root of 16 times square root of meters times square root of meters. Square root of meters times square root of meters is meters. Square root of 16 is 4. Root 6 times 4 times m is 4 root 6 m. So x equal to 4 root 6 meters. That is, the length of this red line which we are asked to calculate is 4 root 6 meters. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.